In this video I am going to explain you about another topic from mathematical method of physics, that is probability distributions. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. Let us start. So first you should know definition for probability. In exam, KSET or NET exam, one of the question from this topic is compulsory. So let us discuss. So probability definition you should know. Probability is the numerical measurement of degree of certainty of the occurrence of an event that we are not sure whether it is going to happen or not. That's why we call degree of certainty of the occurrence of an event. So if an event A can happen in m ways and it fails in n ways, then the probability of event A will be equal to m divided by m plus n. So probability of failing an event, you can take A prime, that is P prime of A is equal to n divided by m plus n. So probability of an event, if you want to define, number of events or ways favorable to A event divided by total number of events or ways. So there are different terms we are involved while discussing probability. So sample space, random experiment, trial and event, equal like events, independent events, mutual exclusive events, and conditional probability. So one of the example I am going to discuss with you, that is, what is the probability of throwing an event number in case of dice. So that is, if we consider dice, there are 6 faces. So we should write probability P is equal to, that is 3 divided by 6. 3 is what, getting even numbers. 2, 4, 6 will be favorable cases, and 6 total number of outcomes, because they have asked even number. So even numbers going to be 2, 4, 6. 1, 3, 5 are odd numbers. So 3 are even. 3 divided by total, how many events are there? 6. Total number of outcomes. So 3 divided by 6 is equal to 1 by 2. So this is how we can calculate the probability. So random variable, it is defined as a real number x connected with the outcomes of a random experiment. So there are two types, discrete random variable and continuous random variable. So x take discrete values here, and x here takes continuous values. So example for discrete random variable, here 2 coins are tossed together. So the sample space will be given by, you may either get head or head and head, tail head, head tail, or tail and tail if you toss 2 coins. So another example for the second one, continuous random variable, that is height and weight of a student in a class is a continuous random variable. So discrete and continuous difference you should know with the example. Probability distribution. So very important, compulsory one question will be from probability distribution. This gives the all possible outcomes of a random experiment with their respective probabilities. There are two types, discrete probability distribution, continuous probability distribution. Then we are going to have the important types like binomial, Gaussian and Poisson. So first you should understand discrete and continuous probability distribution. So discrete probability distribution, let us take x as the discrete random variable. So xi, if we take, I may take the values from 1 to n, and p, probability of this x discrete random variable, we can write it as p of xi. That is going to be 1 for discrete probability distribution. Summation of p of xi is equal to 1. So mean of the discrete probability distribution is given by mod of x is equal to summation of xi n equal to 1 to n p probability of xi. So this is the mean of this distribution. Variance and standard deviation. So this is sigma is standard deviation root of variance. So variance is what? Sigma square. So these formulas you must know to calculate a given problem. Here let us take one example. A dice thrown. Here the example I can take this one. A dice thrown and the outcomes are observed. Find the mean, variance and standard deviation of the random experiment. So if we consider dice, how many faces are there? 6. So 6 outcomes. So probability of getting each face is what? 1 by 6. So p xi is what? 1 to 6. P of xi is what? Probability 1 divided by 6 for all the 6 events or 6 faces as we consider on the dice. 1, 2, 3, 4, 5, 6. So mean formula you should know, as we have discussed here. Mu is equal to summation of xi p of xi. Xi is what here? 1 to 6. P of xi is what? 1 by 6 for all the events. So multiply x and p for all these 6 events. You will get the mean 3.5. Variance, if you want to calculate, sigma square, that is what the variance. Here xi minus mu square p of xi. Mu, how much we got? 3.5 here. So use this mu value and subtract in each of the event 1 minus 3.5 like that. Here I have written 1 minus 3.5 up to 6. You have to subtract mu and multiply with the probability 1 divided by 6. So you are going to get the variance 2.9. So standard deviation is root of variance, that is 2.9 is equal to 1.7. So like that you have to solve the given problem on the discrete probability distribution. So next one, continuous probability distribution. We can define it as, so let us take x is the continuous random variable and the continuous probability distribution of the function is given by f of x. So the integral of this f of x is equal to 1 for the limit minus infinity to plus infinity. So this is for continuous probability distribution. We have to take the integral of the function, that is f of x, that is equal to 1 probability. So here limit we are taking minus infinity to plus infinity. So here in this case mean is given by n into p and standard. N is what? Number of events, p is probability, variance n into p into q, and sigma standard deviation n into p root of npq. So let us take one example here for continuous distribution. So these are the variance and standard deviation formulas for this continuous probability distribution. Here we have to take integral. Suppose, consider this example. Suppose x is continuous random variable with probability density function given by f of x is equal to k into x, where x lies between 0 to 2 and x that is equal to 2k when x lies between 2 to 4, and minus kx plus 6k when the value lies between 4 and 6. What is the value of k and mean of the distribution? Here we have to calculate value of k and mean. So formula to calculate mean is equal to mu is equal to n into p. So first we should write the continuous distribution condition, integral f of x dx equal to 1. So here they have given three conditions for different limits, 0 to 2, 2 to 4, 4 to 6. So f of x is kx, 0 to 2 limit 2k, and another one. If we integrate with respect to dx, here we are going to get k equal to 1 divided by 8. So k is 1 divided by 8, and mu, that is the formula to calculate mu here for this continuous distribution, minus infinity to plus infinity x into f of x dx. So f of x for all the three you have to substitute here again. Then you have to integrate with respect to x. You are going to get mean 3. So like that you can solve the given problem for the continuous probability distribution. So very important. So this is the formula as I discussed in the above example for mean of for continuous probability distribution. So next one is binomial distribution. Binomial distribution can be used under the following condition. First one, a random experiment is repeated many times but the number of trial will be finite. And second one, there are only two possible outcomes, success and failure for each trial. All trials are independent of each other. So this is what the binomial distribution. You can repeat the random experiment but the trials are going to be finite, and only two possible outcomes, success or failure, and third one, all trials are independent of each other. So we can write the probability distribution for binomial, that is given by this equation. P of r is equal to NCR P to the power r q to the power n minus r. N is what? Total number of independent variables. R, number of success, probability of success in single trial. P, q, probability of failure in single trial. So mean, so in the last discussion I have discussed these are the mean, standard deviation and variance for binomial, not for continuous distribution. Okay, so for continuous, mean variance are given by mean variance and standard deviation are given by these three equations. So please, these are what for binomial, don't confuse, get confused. Mean of distribution for binomial is n into p, standard deviation root n pq, variance sigma square n pq. Find the probability of getting one of the example for binomial distribution. Find the probability of getting at least 4 head in 5 tosses of a fair coin. So first you should write number of trials here 5, number of success r is equal to 4 or 5, and required probability is what? We can get p function of 4 plus p as a function of 5. Then you can solve this example here. P as a function of 4, p as a function of 5, that is the standard formula for binomial distribution is what? This one. So put the values n and r in this equation. For p as a function of 4 and 5, calculate, you are going to get the binomial distribution, that is 3 divided by 16. So the next one is Poisson distribution. Poisson distribution is limiting form of binomial distribution. So some of the conditions are given here. A, the number of trials are infinitely large In case of binomial, finite. So here infinitely large, n tends to infinity. The constant probability of success for each trial is infinitely small. Success rate is less, so p tends to 0. Np is a finite quantity, n into p. So let us write the formula for this Poisson distribution. If a random experiment is repeated n times, then the probability that event A will occur r times is given by the equation P of r, Poisson distribution probability P of r is equal to e to the power minus m to the power r factorial, where m is the mean of the distribution. Mean of the distribution we can calculate using this formula. Expectation value of x is equal to n into p. Variance sigma square np. Standard deviation sigma equal to root of np. Here Poisson distribution only q is not there. P only considering n into p. In binomial we are going to consider n, p, q. So example for binomial distribution. 10% of the tools produced in a certain manufacturing process turn out to be defective. Find the probability that in sample of 10 tools chosen at random, exactly 2 will be defective. By using the binomial distribution and the Poisson distribution, both we have to calculate here. So 10%, here the condition they have given, 10% of the tools produced in a certain manufacturing process turn out to be defective. So here the probability of defective tools is p equal to 0.1. Let x denote the number of defective tools out of 10 chosen. So 1 divided by 10, 0.1. According to binomial distribution, P of r is equal to 2 are defective. So r is equal to 2. So we use the binomial distribution formula and put the values of n and r. You can calculate the binomial distribution. You are going to get 0.19. Similarly, we have for Poisson distribution, m is equal to mean m is equal to n into p. So n is 10, p is 0.1, that is 1, mean is 1. According to Poisson distribution, the formula, you have to put r and n value here, m and r value, m to the power r, e to the power minus m, r factorial. If you put m and r value, the Poisson distribution is 0.18. So like that you have to solve the given problem on Poisson distribution. So last one, that is Gaussian distribution, or we call normal distribution. Gaussian probability distribution function for a continuous random variable x is given by f of x is equal, this is the standard formula, f of x is equal to 1 divided by root 2 pi sigma standard deviation sigma exponential minus x minus mu whole square divided by 2 sigma square. So here the terms mu, mean of distribution, mu lies between plus or minus infinity, sigma standard deviation of the distribution greater than 0, and replacing x minus mu by sigma. If we replace by z in the above formula, we can write 1 divided by root 2 pi exponential minus z square by 2. We get the probability distribution function for normal distribution, where mean of the distribution mu is equal to 0 and sigma is equal to 1. If we replace this ratio by z and mu is equal to 0, sigma is equal to 1 for normal distribution. Normal curve, its property, you can see the nature of graph, it is going to be like this. Continuous distribution, it is having the bell shape. Here x is equal to mu, mean value, sigma is given by standard deviation on the either side, left and right side, mu plus sigma, mu plus 2 sigma, like that, mu minus sigma, mu minus 2 sigma. So These are the conditions for Gaussian distribution. The curve is symmetric about x equal to mu and extends from x equal to minus infinity to x equal to plus infinity. Here in this curve x equal to mu, that is what the curve is symmetric about right and left side. B, the curve attains a peak value about x equal to mu. Okay, as we can see in the graph, x equal to mu, peak value we obtain, that is maximum peak value for the function is equal to 1 divided by root 2 pi sigma. So this equation we are going to get. Third one, as we change x and on both sides from mu, y decreases rapidly. So if on both sides you can see the if we add x to mu, x mu plus sigma, then here on the both side it is going to decrease. So the last condition, area under the curve is the measurement of probability for random variable.